My name's Professor Dave Worsley. Now, I've been mentioned a couple of times, and I was from Swansea University, but my first reference is to this. Fans of 90s comedy may remember Newman and Baddiel, and they used to do a sketch called History Today, where two professors would basically slag each other off. See that new solar panel? It smells of poo, that sort of thing, right? And I've grown weary of that constriction to what we need to do. So I've left Swansea University, and now I'm hoping to push things a bit more aggressively on the renewable energy front, particularly in Wales. Now, so I can just set a context for myself. I love minis, yes. I'm the worst kind of environmentalist because I like the environment, but I also like burning petrol. Oh no, and so I've got, Mini Coopers of different sizes. I've got a Cooper S Works, a Chinese electric car. Oh no, God, I'm really rowing myself into a terrible state. But the thing is, we need to adapt our products and so on to support the lifestyles that people want, not force people down a track that they don't want to be in. So I think the exciting thing about today's launch is it builds on a lot of history today. Me and Daniel were young folks. I had hair. Daniel had still the same amount of hair, but slightly darker. And just a couple of points about where I got interested in engineering. Right, my dad was a collector, an avid collector of photographs, historic photographs. Brunel's biggest ship there ended up being too big to use, really. So it ended up marooned in Pembrokeshire, where I'm from. And that's a picture of it, dominating the Neyland sort of skyline. And then these folks here are Irish navvies who were building his railway system down to Fishguard, which was going to be an Atlantic port. It's not an Atlantic port, it's a very small place. I went to school there, right? But it's about, why are these important? Well, firstly, it's probably shortened my life by about 20 years, because my dad used to develop these prints in our bath at home, because, so then get in the bath, child. It smells of sulphur, Dad, I don't like it. But it did give me a feeling for what engineering was about, and it got me excited about it. What also got me excited was my dad's own pictures, right? So talking about roofing materials from Wales, that's it in the old days. So that's the North Wales slate industry, right at its sort of end point in many respects. And you can see why, because the conditions there are not suitable for humans, really. As the gentlemen concerned are protected by a small piece of tweed and some exuberance, And Dinorwic is also an important place for renewable energy, and that's where I got excited about renewables first. Because the power station at Dinorwic, which is the thing that balances our power at certain times of day, was built on the site of the former coal mine. And I went there in the 70s with my dad, and we drove down, well, I didn't, obviously, I was only very small, not that old. We drove down in the tunnel in a Land Rover between the two lakes, and again, that gave me a slight fascination for Land Rover products, so they are also in my collection, sadly. I had a period of time, I now sometimes look back and think it was the wilderness years. I was a chemist, right? Not like the one that sells you drugs. I wasn't that adventurous, but I spent a good 10 years trying to make hydrogen directly from sunlight and water, so water splitting. I think some of this stuff might come back into fashion at the time, but in the 1980s it was fanciful. And then in 1994, and get ready for this, is a picture of me in 94, look at that, way. I met this scary man who's now sadly dead, and he said, "Worsley, there's only 3 things certain in life: death, taxation, and corrosion." So suddenly I discovered that actually I could use all my electrochemistry that I'd learned about in solar to look at rust. I was a proficient expert in that, being the owner of a 1994 Mini Cooper, which lasted about 3 years. And this links to Shotton and Tata, because obviously I was working with British Steel as it was then. And we developed jointly with the guys new galvanizing coatings, new paint systems, all of which have enabled things like the Catnic product to have like a 40-year guarantee. But at the same time, you know, you reach a point and you go, well, what are you going to do? What are you going to do next? And I think Daniel and I and a couple of other colleagues were looking at Shotton's output, 100 million square meters, pretty much of stuff that sits outside all day long in the rain, in the sun. We thought, well, what happens if you put a solar cell on that, about 10% efficiency? And actually, when you do the calculations, when you take 10% of their production and put a 10% solar cell on and put it outside, you get a gigawatt peak of power. And it's like, oh, right, okay, so that's what we should be doing. So that's a tipping point that occurred to us. And it's not new thinking, really, because Thomas Edison, you know, arguably one of the innovators of all time, you know, made that statement in 1931 about solar energy. It'll be 100 years since he made that statement soon, and we're still going, yeah, but what about if we burn some gas, yeah? How about drilling some more, yeah, drill, baby, drill. And then, you know, the solar fact works for us because, you know, every day more energy falls on our Earth's surface than we'll use in 27 years, right? So that brings me on to a somewhat more controversial topic. Narcissus staring into the black pool and not actually hearing the angels from above, as in the solar angels or the photons, you know, telling him he should stop looking at himself and underground for energy. That's what I've interpreted it as. He should look upwards at the sun, because that's where the future lies. Now, this is where I apologize to any Republican voters from the USA. Because, of course, the Don is telling us that we should be drilling and digging, and, you know, my comment to that is just stop it already, right? We've done enough. We don't need to burn things anymore, you know, to get the energy that we need. There's a time and a place for burning, and that's in my car. Right. My vision is shared by others in the room, but also by other countries. So this is a video from Japan, not of a CGI, but this is Daiwa House in Japan, who have a kind of model village. Now, obviously, the PV's not integrated, so, man, we could make such a better job of it. But imagine all of the new developments in the UK being like this, with solar roofs, fuel cells, plug-in vehicles. It doesn't mean that everybody has to have it, but it is the way to do it. And the way to do it is through these 1, 2, 3, 4, 5. There are 5 Ps, or 6 if I had passion, which hopefully before we have lunch I can persuade you of. That's another P. I'm alliterating for Britain, yes. So the purpose, firstly, eliminating fuel poverty, right? We shouldn't have fuel poverty in the UK. We're a developed nation. We're beyond where, you know, Granny has to turn on an electric fire. The worst kind of heating in terms of money and everything, and the fact that Granny's soon going to be on fire. You know, it's not the right thing to do. And yet, you know, across the UK, huge quantities of our population are in fuel poverty. When you've got a solar-powered house, you're not going to have fuel poverty. You haven't got an energy bill to worry about. And that will create economic growth locally around those areas because people will buy more stuff. They can even go out and buy a Mini Cooper S. I've got a few for sale, yes. If we come down to energy, this is now, well, 10 years worth of data from Grant Wilson, lovely Scottish dude, works in Birmingham Uni. And the blue line is our gas consumption. And it hasn't really changed much. And it goes massively high in the winter and down to almost very little in the summer, in many ways. That's our heating. So, right, okay, if we can electrically power and heat our buildings, most of that big peak can be chopped out. We can't do it with our current electricity infrastructure because the red line is our current electricity provision. But we can do it if we go back to remembering that all that solar energy is landing on the surface of the Earth. And we also think about wind energy, particularly things to do with made of steel, floating offshore wind, small nuclear, tidal barrages. I mean, people have been talking about a tidal barrage in Swansea for decades. It's not happened. Severn barrage. My colleague Ron Stevens, who's the dad of Joe Stevens, Minister for Wales now, he wrote a report for the Wilson government explaining how the Severn barrage could power 10% of Britain. And it's still not happened, right? So my frustration in life is actually, let's do something, right? Let's make something happen. And this is where myself, Tata Steel, and Daniel had our first interactions. This is our active classroom that Daniel showed before. It's 2D modular construction, right? And you can see it rains a lot in Swansea. There's a frame goes in. You can build your thing quite quickly. It's only a couple of people doing it. If you make a mistake, yes, we did, you can take it apart and then put it back together again. Wasn't my mistake, just saying. Or indeed anyone in the room. When you're ready, you'll see the PV go on. The roof's there. Whoop, there's the PV. It's on, right? So the roof's on straight away. So this building was our first active building. It had solar thermal heating. It had solar PV on the roof. This was like trial stuff that Daniel had made and the team. It had no guarantee, no warranties given, implied or suggested, right? But in fairness, the university took a punt on building this building because we were able to persuade them to do it. We also had on there a Tata Steel product called a transpired solar collector. More on that later. It's another brilliant thing that needs to be applied more often, because we often forget about heating. And this building has worked brilliantly for the last, gosh, it's got to be 10 years. Yeah. The next one we did was, and thankfully the sound's not playing, because Wernick put some extraordinary music to this, right? If you need rousing later on, right, listen to the music on this. It'll rouse even a dead person. But the active office was, again, modular construction, but this time 3D modular. There's a time and a place for both of those, and for this sort of building, it's perfect. We had to design and build this building, Jan, probably within 6 months, wasn't it? Yeah. So we had some money, and then we had to design it, build it, deliver it, finish it, all within 6 months, right? And people normally can't do that, because it's like, well, have you thought about planning? Well, no. Luckily, we're in Leithport Talbot. They're a very good authority. The advantage on this building was we were showing the use of Daniel's second phase, first manufactured product, on a curved roof. Why? Well, one, it looked a bit nicer, but two, you can't make a silicon solar cell in a curved roof format. So we've got the standard roof on the classroom, the curved roof on the active office, and battery systems, Chinese sadly, but very cheap. And on the side, we also showcased an Imperial College product called a PVT system based on evacuated tubes. They'd only made 3 of those, and they got a bit surprised when our guys asked them for 50. But again, it's trying to accelerate innovative new products. We've used that building to run my car, my last Nissan and my Chinese MG for 40,000 miles. Yes, for free. Thank you very much. Maybe I should have stayed at Swansea University. I could continue to charge my car. And the buildings themselves have been, instrumental in showing that this sort of technology can work, right? It wouldn't be a scientific, so-called scientific presentation without some sort of graph, right? So here's a graph, right? But the interesting thing is you'll see that the photovoltaic roof generates power pretty much all the time. Doesn't matter what conditions. If you had this as a silicon one, it'd be very much more peaky in the summer months and not so generating things. There are some days where it almost generates nothing, but there are some days in South Wales where there are no photons. It's dark. The little blip there where there's no data, that's when actually we were building a new building, which meant that the whole thing had to be disconnected from everything. So we lost a bit of data. But the interesting thing is, even though the building's now got shadow on it, in the first year of operation since, it's still generating similar amounts of power that it was before. So the statement about using this material and getting good performance in low light is a true one. Right. Some active homes stories, let's say, yeah? This one you saw before, and it was a great project, and it's some social housing in Neath. First rule of making social housing or making any kind of house, follow the instructions. You know, remember to put in the insulation, you know, when you're using a mechanical heat ventilation recovery system, don't put in giant air vents into the side of the building and a dustbin-sized chimney on it. So it was a learning point for me, and it was right in the middle of the pandemic, I think we can say that. And, you know, the buildings will have never performed in the way that we might have hoped them to because they weren't executed very well. So, learning from that, Cal and Jan-San, you can talk to them later on about this. Jan-San will appear without sound. Jan, I've muted you, right? But this was using a Daiwa house from Japan, our colleagues from Daiwa House Europe. Hello, there they are. It's off-site modular construction, so effectively it was sort of watertight in, what, 6 days, something like that? Yeah. And the nice thing for me, well, can I just pause the video there? Oh, no, go back a little bit. Right, whoa. Play. I tried this with some students earlier in the year. I've realised I have to stand back here to see my computer as well. Yeah, I've got plenty of time. So, right, here we go. That was it. Oh, what is he trying to show here? What is he trying to show? Come on, get to the bit that I want. This is what happened when I tried to show my students, right? Oh, there's the blocks going together, right? And there's lovely boy Daniel talking about his houses. I keep going back to the beginning. Right, I'm going to leave it run, right? Forget it. When you see the buildings, right, look at the two on the end compared to the ones that are adjacent, right? So the two on the end, it will be worth the wait, honestly. That's what I've told my students all my life, and they were glad when I left. Yeah, yeah. So I think it's fair to say that Amanda's computer has a different mechanism. I suppose because I have a touch screen. Yeah. It's a Tata computer. I'm surprised I'm allowed on it. I'll probably be banned later on, right? But when this pans around and you see the finalised buildings, look at the size of the windows on the ones on the right and the ones on the left, right? So the ones on the left are from a former UK modular provider, let's say, and the ones on the right are from the Daiwa House folks, and they've got much bigger windows, right? And they've got a bigger space inside. There's no gas connection. You don't need a gas connection. It's electric. That's the feature. There's Jan-San. Oh, hello. Yeah, there's lots of good things we learned about that project. And also, one of the things I think that personally I'd like to see us venturing more into is 2D modular, because moving them big boxes around is a bit of a bugger. That's French for difficult, by the way. On the Bay campus, we built this modular building, luckily just before the pandemic, because then we could use it as a vaccination centre for all our students, yes, who were encapsulated on the campus and couldn't escape. But this, again, is you know, why don't we make all buildings in this sort of way? Why don't we just manufacture them? The quality's better. You know, there's lots of steel in there, which is great. There's room for timber. And on this building, as part of the Active Building Centre project, Andy and his colleagues installed, I think, 135 kilowatts peak of PV and a sort of 1 megawatt hour battery store as well to make it part of the campus's energy system. During the pandemic, we also had this interesting experience of delivering an active classroom 2 hours north of Mumbai in a village that had no electricity. Zoom meetings with no electricity, that's complicated. But in fairness, the team did it, and the active classroom there is powered by BIPVCO stuff. And what's interesting is the follow-up work that our colleagues are doing. They really like the building, and what they're using it mainly for is refrigerating jasmine flowers so that they can sell them at a premium when everyone else's jasmine flowers have dried up, right? So it wasn't expected. I was expecting them to have a massive beer fridge, obviously. Another project that we're doing down with us is a hydrogen filling station with a Japanese firm called Marubeni. My colleague Jan is here, and she can tell you a bit about that, because I'm going to get a crack on now, because otherwise the sandwiches are going to go off, and they'll be full of salmonella or something. And in Neathport Talbot, we've got a lot of interconnected projects all around low carbon growth, and working with Neathport Talbot as an authority has been brilliant. Wales in general is a great place to do this stuff once we actually align all of the pieces in the jigsaw puzzle, because there's not quite so many lines of communication that need erasing before you actually are able to build and do something. And in Neathport Talbot, we've got already a hydrogen centre and our specific grouping and a new technology centre. We're building something called Switch Harbourside, which is going to be about supporting the new steel industry in terms of technical innovation. And although I've left the university, I'm going to be heavily involved in that, but as a kind of agent provocateur, whatever one of those is, focusing in on new materials. And we also have other interesting things in our midst relating to the King Charles. We have this set of buildings, a little village that was built on the former BP site, which is it can never be occupied, it can never be used, there's loads of complication around it. But if you wanted A, somewhere to do retrofit demonstration, and B, somewhere to film a comedy series about Welsh people killing each other, that's it, right? So, that's going to become part of my new obsession, right? Plans going forward, printed photovoltaics. Okay, Daniel does 2nd gen, this is 3rd gen photovoltaics. Printing and coating using things that you can make t-shirts with. So the centre photograph with the Volkswagen lady, she's a student from our place. She's so Mexican man, I don't know why I'm speaking like that. She showed the Mexican man how to make a solar cell using his t-shirt printing apparatus, right? And it works, right? So this sort of stuff is a way that we can onshore photovoltaic manufacturing in the UK and deliver, I think, low-cost PV integrated into large construction products, because that's the way to maximise their manufacturing potential in the UK, and embrace some of the learnings that have come out of UK universities. These are some of the largest glass, see they're not that big yet, but A4 modules produced by anyone in the world yet so far on perovskite. And that long dangly thing is the world's first continuously printed perovskite on plastic module thingy, which is next to our rather nice active buildings. Heat. Got to talk about this. This is another product that Catnic and colleagues should be selling more of, and colours. It's perforated cladding. It's cladding with holes in it. The holes were specifically designed by me and colleagues so that they won't ever rust, right? And this has been on this building, providing heat to the building with no gas connection. It replaced a 220 kilowatt gas boiler 12 years ago. And it runs year-round, collecting heat, pumping it into the building. All big sheds should have one of these on it. Don't forget about heating. We can use waste heat as well. So in the discussion about, what was going to happen to Port Talbot, this photo I took from my office in the Bay campus, and I think God was trying to say something. I never was able to translate what it was, whether it was keep the blast furnaces or shut them, I'm not sure. But, we've gone one way now, but whatever we do in the future, there's still going to be lots of waste industrial heat. We should use that. The waste industrial heat from the steel plant was enough to heat 500,000 homes. That's, you know, that's most of South Wales. And all we need to do is turn it into something which you can move around and use as heat. And boffins, you know, like my two colleagues there who were just on there, they know how to do it. We've stored it in the shed in a Tata project, which Daniel was involved in as well. In a shipping container, right? And you can store heat interseasonally. You can stave it in the summer, use it in the winter. You can move it around. You can go to Tesco's probably. Other supermarkets are available, but I like Tesco's. And you can buy a bag of heat. Why not? Yeah, why not? Stop saying why we can't do something, and I won't get into the difference between a can and a can't, because I did that once at the Newport Metallurgical Society dinner, and it was misunderstood. Finally, last thing though is about training. People with passion. This is going to occur through people power, and those people need to be in the schools, and they need to be in CPD, they need to be relearning things at work, they need to be doing apprenticeships, they need to be going all the way up to PhDs, which I've managed to chop off for some reason. I don't know, there's no offence to my former employer, but you know, we need to do everything to enable a seamless education and get the accurate information across to people, because otherwise Farage and all his buffoons will just fill our ideas with heads with drilling, digging. You know, South Wales will be opening coal mines. You know, we don't need to do that. We did it before. We don't need to reopen the slate mines. It's dangerous, right? We can use the slate waste, I'm sure, for something, but we can move on. It happens through passionate people and education. And the final slide is just to thank my own collection of passionate people when we were out. Some of them are here in the audience. Thank you, passionate people, for your passion. And those are some of our friends from across the world when we met in Delhi last to discuss solar energy. And all of that resulted in us getting a Queen's Anniversary Prize, which was very gratifying and gave me the opportunity to have a couple of days away with our new Vice-Chancellor, where I told him exactly what I thought of Swansea University. I've recently left Swansea University. So, a final thanks then, you know, to all of our friends and sponsors, both the UKRI folks, BIP, Vico, Tata, Nippon Sheet Glass as well, you know, Pilkington's, to other people, and BASF. And of course, I got a shout out, Jansan, have I not? The European Union. Yay. Because a lot of Wales's innovation funding, which now doesn't exist anymore, used to come through ERDF and ESF channels. And we need to try and rebalance that, because at the moment that's meaning that ideas are being created and no one's ever going to explore them beyond the laboratory phase, because there's no mechanism to drive forward. Thank you very much, and now we can have a sandwich.